Physics is woven into the very fabric of our daily lives, often in ways we might not immediately notice. Everyday objects and activities, from the simple act of riding a skateboard to watching a ball bounce, are governed by the same fundamental laws that scientists study in laboratories. These ordinary experiences provide remarkable insight into the principles that shape our world. Consider the skateboard, a seemingly simple invention consisting of a wooden deck mounted on 4 wheels. When a rider pushes off the ground, they apply an external force, propelling both themselves and the skateboard forward. This motion is a direct demonstration of Newton's second law of motion, which states that the acceleration of an object depends on the net force acting upon it and its mass. The lighter the skateboard, the quicker it accelerates under the same force, giving riders greater control and agility. This is why professional skateboarders often select boards that strike the perfect balance between weight and strength, enabling them to perform complex tricks with precision. Yet, as the skateboard rolls, it gradually slows down and eventually stops if the rider ceases to push. This is the work of friction, a force that opposes motion and acts at the contact points between the wheels and the ground. Though invisible, friction is powerful, governing not only the skateboard's movement, but also ensuring the rider doesn't slip uncontrollably. The design of skateboard wheels, their material, and the texture of the riding surface all play crucial roles in managing this friction to provide both speed and safety. Gravity, the ever-present force pulling objects toward the Earth's center, is another key player. It keeps the skateboard and the rider firmly grounded. But when a skateboarder performs an ollie, a foundational trick where both the board and rider leap into the air, gravity's influence becomes even more apparent. To execute an ollie, the skateboarder crouches, storing potential energy in their bent legs. As they jump and snap the board downward, this stored energy converts into kinetic energy, propelling both upward. The motion follows a parabolic arc, characteristic of projectile motion, until gravity slows the ascent, halts it momentarily, and then accelerates the descent. Air resistance, though less significant than gravity, subtly affects the height and distance of the jump, demonstrating how multiple forces can act simultaneously on a moving object. The skateboard's design itself is a product of applied physics. The concave shape of the deck isn't just for aesthetics. It distributes forces more evenly, enhancing stability and maneuverability. Materials are chosen for their strength-to-weight ratios, ensuring the board can withstand repeated impacts without being too heavy for tricks. Even the trucks and wheels are engineered to optimize performance, balancing speed, grip, and shock absorption. Turning to the bouncing ball, we find another everyday marvel of physics. When you hold a ball above the ground, it possesses gravitational potential energy. Release it, and gravity accelerates it downward, transforming potential energy into kinetic energy. Upon striking the ground, the ball compresses, storing elastic potential energy in its deformed shape. If the ball is made of a highly elastic material, much of this energy is returned as kinetic energy, causing it to bounce back up. The height of the bounce depends on the efficiency of this energy transformation. A rubber ball rebounds impressively, while a clay ball barely lifts off. Each bounce traces a predictable path, governed by the same laws of projectile motion that guide a skateboarder's jump. The arc of the ball, the loss of height with each bounce, and the eventual rest are all dictated by energy conservation and the gradual dissipation of energy through heat and sound. From skate parks to playgrounds, the principles of physics are at play, shaping design, performance, and safety. Engineers and designers harness these laws to create better, safer, and more enjoyable experiences, proving that physics is not just an abstract science, but a vital part of the world we live in every day.